Yeah. Yeah. Okay, guys. uh, okay, let's continue. I'm sorry, the problem is with the network. I mean, some automatically it just got logged out of from the network page. Okay. Yes. And we are going to extract our images as batches of size 32 as we have defined in our configuration file, which is fine. And yes, it would is going to take around 15 minutes. I'm going not going to spare that much of time here, because at least it is having it. Yes, it is going to take lots of time, also lots of GPU power. I don't want this particular live session should be hanged on middle. So since I have very limited GPU, which is 2 GB, so it would not be fine if I'm going to live stream and also doing the same training on the GPU. Okay, so now that we have extracted our HDFI features, and now we are going to train a logistic regression model on that, on top of it. So we are going to extract our stored features from HDFI store, as the shape will be 8704 by 3072. We feed it to the logistic regression, and yes, we will get the predicted model here. Yes. Let us see how the actual training looks like. Okay. uh, this script actually trains our overfit features. Okay. uh, we are just going to pass our arguments. It is just going to take a single configuration file as before. And yes, we are going to load our configuration file into the memory, and then going to load our HDFI file, so which is defined here, features. So okay. And also we are going to load the saved label encoder, okay, in this path. So yes, we are going to split the training, and we are going to split the image IDs as here. 75% of the images should be used for training, and then remaining 25% are used for testing. So that is what we are doing here. And we are splitting the training and the testing sets. We are transforming the labels for the training and the testing, and then we are defining the logistic regression model with inverse regularization parameter of 0.1, and we are fitting the training data and the training labels. Okay. And then we are initializing rank 1 and the rank 5 as 0 0. So I will get into this particular rank 1 and the rank 5 later on. So just continue with our work. Okay. So we are just actually, we have fit our model. That means we have trained our model, and what we are actually doing is evaluating the model in order to find the accuracy. So rank 1 and the rank 5. So we just need to extract the top probable predicted probabilities for a particular image, and if the predicted probability at the very top level is equal to the actual target of the image, then it is rank 1. If the predicted probabilities, we are having a set of predicted probabilities and we have a target, and if the target is in the top 5 predicted probabilities, then it would be in the rank 5. So we are going to see how much of we are having the rank 1 and how much we are having the rank 5. So I'm just argument sorting the predicted probabilities here, nothing more than that. And yes, I'm going to find the rank 1 and the rank 5 here in order to see our model accuracy. And yes, I'm going to print the classification report with the test labels and the predictions. And yes, the predictions are for the test data. And I'm just writing our model and saving our model, dumping our model to some closing that file and the open database, the HDFA file store. We just need to close that. So now we have trained our model. So after training our model, I have achieved 0.89, which is 90% F1 score with precision 90% and recall 90%, which is fine. And the rank 1 I have got is 90% nearly, and the rank 5 is 97%, which is fine, absolutely fine. So it means 90% of the times, whatever the prediction it says at the very first predicted probability is true for the rank 1. And considering the rank 5, so if we give an image and we predict the probabilities of the top 5, so the actual target will be in those 5 90%, 97% of the times. Okay, so that is the thing. Okay, now that we have trained our model, so how can we actually interact with our trained model? We need to build some API for that. So for that, I have written a script classify.py. You just again we start off by importing our argument imports. We just build an argument parser which just takes an configuration file and an external image. Note that this particular classify file will be taking an image from an outside, not from the dataset, and it just predicts the probabilities. Yes, it just predicts the label. If you're going to give an image of a car, we will be getting the car instead of it doesn't, that image doesn't belongs to the testing set. Okay. Yes, this particular constructor needs to have the configuration file path, which will be defining here. So it just loads in the configuration file. Also from that configuration file, it just loads our model, also the label encoder. Also, it is just going to take over the overfit from the sklearn Theano. Since we are working with different image and we have not extracted the features yet, so we need to pre-process the image first. We just convert the color to RGB, and then we just resize to whatever the image size we have defined here, which is 231 by 231. Okay, and then we return the image. So after that, we need to extract the overfit features. After pre-processing the image, we just transform the image. That's it. Okay. And we just return the features. That's it. And we have a predict method which takes in an image path. It just reads the image. It just extract the features from it and just feeds it, to the model and predicts the features. And also we just return the actual label. It just predicts. So label encoder, we just outputs whether it is a label of 1, 2 or 3. We just not need that. We need whether it is a car, whether it is an aeroplane. So what we have done when we have extracting the features is that we have built a label encoder which actually passes that. So we are just inverse transforming that. That's it, nothing more than that. So if we run the script at the very main levels, and then we will be doing this. So we just build a classifier class here. We just predict by giving the image path. That's it, nothing more than that. So using this class, we can just predict any image. So let me show you an example for that. So let me download an image of an Obama, and let me see whether it is predicting correctly or not. Since our training data set didn't have an Obama image, we just have the faces. So if it says if it is a face, then definitely our model is on that. Okay, the network is taking too long. I don't know why. I don't know. Maybe the live streaming, the network latency is something. Just for that. Image. Let me see it. No, no. Why it is not working? I don't know. Let me stop the tensor board. It have been completed. So let us feed this particular image and then predict whether it is. So this image will be fine. It is somewhat less in size. So let me save this particular image and just so we need to give in the configuration file for loading the image size and the configuration what we have defined, and the image is going to be test one.jpg. Let us see whether it is going to predict it as a face or not. So let's wait for a moment. This is the very first time I have, you know, triggered the Escalon piano module in the GPU, so it will be taking some much time the very first time. So from the next time it would not take this much time. So yes, it have correctly predicted it as a face, which is fine. So let us quickly also give it another image and try it. Therefore, you can predict whether it is a car or not. Just to test two. It will be, the image will be test two image, and let me see. It wouldn't take that much longer as before because we have already triggered the GPU. Yes, this is a car side. Yes, this is a car side, which is fine. And let me check out with other examples. Let me take this particular image and test it. And if it is going to output as a Buddha, then okay, we are fine. Otherwise, we are not. So yes, we are fine. The model is perfectly all right, and We have also already seen that our model have acquired achieved 90% accuracy, which is fine. 90% rank 1 and then 97% rank 5, which is obviously fine. So so let's test with our testing set. I mean, images from our testing set, which will be okay. Yes, these are the things from our these images are from our data set. So so this is a laptop, okay, that is fine. Grand piano, motorbike, okay, motorbike again, and yes, this is a Buddha. So note that these images are from our data set. So I just showed the images from outside in order to make clear that our model have not been overfitted and it is working fine. So yes, we have finally achieved a working model for classification different kinds of images. At least we have achieved 97 rank 5 accuracy and 90% rank 1 accuracy on Caltech 101. Now that we have 101 categories, and yes, if you are going to train our model with more than something like more than on general categories of something, then we can build an application like this. Yes. Okay. So it wouldn't be an difficult task if you have mastered this. So that is the thing. Also, since we have seen the convolutional neural networks can be of any shape. I mean, it can be of any architecture. So the actual general architecture is we pass the image through all the convolution layers and we just take the output from it and just we pass it through fully connected layers and we get the output layer. So which is okay. We can also bypass the outputs from several convolution layers to some other fully connected layers, which is also fine. So sometimes it would help and sometimes it would not. The actual convolution layers actually detects the edges and the corners, blob-like structures in an image. So it might help the fully connected layer in order to generalize the classes. So uh, yes, we can actually develop a model in order to detect the detect the objects in an image. So RCNNs are region-based convolutional neural networks, which simply uh, classify, I mean, detects the objects in an image. So how that it works means we are going to build an image classifier, what we have built now, and we just find out 2000 region proposals. So this particular image is going to be passed through an this particular image is going to be passing through an selection search algorithm, and it just proposes 2000 regions, and we just again passes through non-maximum suppression, NMS, what we call it as non-maximum suppression. And then we will have a very limited image windows, and we pass each window to our classifier, and yes, it predicts whether it has an each window as okay, this person, horse, okay, this one has a shed, so something like that. It just classifies it. So given an image, it just outputs this part image, person, horse, shed, something like that. So we will be building it later on, so it wouldn't be a difficult task. So the output of a regional based convolutional neural network would be something like this. So yes, you can see it a wine glass, tie, person, all the things. Okay. So that's all for this session and discussions now. So if you have any queries regarding this, and just post in a comment down here, I will be happy. So we will have only 5 minutes for that. So if you have anything to for me to ask, just ask in these 5 minutes. Okay, I will be waiting. I guess nobody is interested in asking. Okay. Yeah, is anybody there? I'm live again. Can you please check out now? Okay. So anybody in live? I don't know whether it is going to work or not. Okay, please come to the YouTube comments. I will be asking. You just ask me whatever you have, any words or any comments. I will be answering them. So how can we download the code samples and the training sets? Yes, I will be providing all the links in the description when I will upload the video after the trimmed version. I will be uploading the trimmed version this night, and the actual links for the data sets and everything will be in the description. Yes, for the sample code, I will be pushing it to GitHub, and I will be posting in the description. Okay. Uh, Yeah, Patrick, that is what I have been saying. And for the code, I will be pushing the code to the GitHub, and I will be mentioning Git. Yeah, PPT also, I will be sharing the PPT too. And how do you feel the session? I guess there are some network glitches, and apart from that, how it is? Yeah, definitely, I will be putting the comments on that. I just stripped the comments. The reason why, but the script shouldn't be very huge when we are actually doing a session. So it would be large if I'm going to insert a lot more comments. It would be confusing. So what I have planned is simply show you the bare bone script, and definitely I will be adding the comments. Don't, no problem. Yeah, definitely. The glitches are kind of like definitely, Patrick. There are some glitches. I don't know it will be happen. And as I have said, this is my very first YouTube live, and also I haven't take care of my network here. So that is the problem. Course, I didn't get you. What do you mean by the course? You mean session, Mr. Patrick? So also remember that we have just implemented a basic model. We have been classifying 101 categories. If you have a very good machine, of course, we can make use of Amazon Web Services to build something like AmazeNet, 1,000 categories. Yeah, okay. Thank you. The session was good. Okay, and looking. Okay, actually, I have planned two sessions a month. One session for experienced people. I mean, what this actual session is, and one for the beginners to motivate. That can be, followed by, I mean, beginners, and it would be handled by some experienced people. uh, they can motivate the beginners how to start and how to get into this field. So that is the thing actually I have planned. And the next step is, it can be sequence classification. And yes, image captioning is also in my mind. Definitely I will be doing image captioning. uh, so yes, RNNs and LSTMs, I will be doing that kind of work. So is that it? Okay, I'm signing off. see you in the next session. Definitely I will be doing on image captioning and sequence classification, and definitely I promise next time these problems wouldn't be occurring again and again. Definitely I would take care of this. Since this is my very first time, I don't know these kind of problems would happen. So the comments. Yeah, yeah, no problem. Thanks, no problem. Yeah, okay, fine. Yeah, I'm leaving. Okay, bye. Yeah, thanks, Sushil, for your kind words. Apart from some network glitches, it would be fine if there is nothing there. Okay, thanks. Thanks, Pawan Kumar, for hosting this particular. If you have wouldn't be there, then definitely this session would have lots of noise. And thanks for providing a place for this. Yeah, okay. Time to leave. Okay. If you have anything to ask me, just ping me in the group. If you don't feel like pinging in the group, then definitely uh, personally message